This is TMUA 2021, Paper 1, Question 15. We're given the graph of the function y equals f of x, and we're also, which looks like these alternating line segments of gradient 1 and minus 1. And we're also given the function g, which is defined to be f of 2 to the r minus 1x, summed from r equals 1 to 10. And we're asked to compute the integral of g from 0 to 1. So let's first write out what this expression is. This is precisely the integral of this expression. What might we do from here? Well, we can swap this sum and this integral other way around. And why can we do that? Due to linearity of integration. So this integral is precisely the sum from r equals 1 to 10 of the integral of f of 2 to the r minus 1x dx. So what is this? So let's consider maybe visualizing what this function is. Well, this is precisely a scaling by a factor of 1 over 2 to the r minus 1 in the x direction. So we're shrinking it by a factor of 2 to the r minus 1. So how does f of 2x and f of 4x look like maybe? So for f of 2x, we know that at x equals 1, f of 2x is f of 2. So that means this point here is sent to 1. Similarly, f of 4x at x equals 1 is this point. So this point here is also sent to 1. So anything to the left of this point is going to be shrunk into this interval of 0, 1. So we're going to get a graph that looks something like this. So for f of 2x, this triangle here is now squeezed into the region 0, 1. Similarly for f of 4x. So how might this generalize for higher powers of x? Well, we notice that these triangles, we get a new triangle for after you pass every 2 units. So that means like f of 6x, for example, we're going to have 3 triangles in 0, 1. So by that logic, we should have that for f of 2 to the kx, we have 2 to the k minus 1 triangles in the 0, 1 region. And what else do we know about these triangles? Well, they'll have a height of 1 because we're stretching these horizontally, not vertically. So they'll have the same height as before. And what else do we know? We also know that they'll be equally spaced in each of these triangles. So they'll have width 1 over 2 to the k minus 1. And this holds for all k bigger than or equal to 1. So what is this integral then? This integral is precisely the area underneath the graph. So it'll be the area of these triangles. So for k bigger than or equal to 1, the integral of f of 2 to the kx is precisely 2 to the k minus 1 triangles times by the height times by the width of each triangle multiplied by a half, as this is the area of a triangle. And you see these two cancel out and we get a half, and this holds for all k bigger than or equal to 1. But what about k equal to 0? Because in our expression we need r equals 1 gives us a 0 here. But when you have k equals 0, this is exactly the original graph of our function, and the integral from 0 to 1 is precisely the area of this half triangle, which has base 1 and height 1 as well. So this also has area a half. So we know that this is equal to a half for all values of k. So our expression for integral of g of x is precisely summing r equals 1 to 10 of a half. And you can evaluate this to be exactly 10 times a half, which is equal to 5. So our answer is C.